This video is about graphing linear equations using the intercepts. Remember the last video we graphed equations by plotting points. We're going to do a similar thing, but the points we're going to look at are called intercepts. Here I have a Cartesian coordinate system in white, and we'll call this x. And we're going to say this is the x-axis. Right? The one that's horizontal, and the vertical I'm going to call the y-axis. And you can see this line, the orange line, my linear equation, graphed here as an orange line, cuts through the y-axis at this location, right? And cuts through the x-axis right here. So it intercepts these two axes. Where the line intersects the y-axis, we call this, wow, what a surprise, the y-intercept. And likewise, where it crosses the x-axis, we call this the x-intercept. Okay. And one other thing to notice is that these are points. At the y-intercept there's a point right here where it crosses, and here at the x-intercept there's also a point where it crosses. So because there's a point, there's an x and y coordinate that goes with that. And the y-intercept will always have an x value because I'm crossing the y-axis. Notice the y-axis goes through the x-axis at the origin, which is the point 0, 0, right? That's right here. So I'm going to have an x-coordinate of 0 always at the y-intercept with some y value. And the x-intercept, well, likewise, it's going to go through the x-axis somewhere along here at some value x, but it's always going to go through the 0y. So I'll always have an ordered pair that looks like that. So these are the intercepts. We can use these intercepts, we can use the idea that either here, in this particular point, x is equal to 0 for the y-intercept, and here, y is equal to 0. We can use that idea to find the x-intercept. So let's do that with an example. Here's an equation, a linear equation in two variables. 2x is equal to 3y plus 6. So we're going to find the intercepts. So find intercepts. And then we'll graph it. So it's just this simple. First of all, let's find the x-intercept. So I'll just abbreviate that like that. So here's the process. I want to find the x-intercept, so let's remember, if I have a line and it's going through, I'll make a different line this time. I'll make a line that looks like that. The x-intercept is right here, so y would be 0. Alright, so I'm going to let y equals 0 in my equation. So I plug in y equals 0, I get 2x equals 3 times 0 plus 6. But 3 times 0 is 0, so 2x is equal to 6, or x is equal to 3. Using these two pieces, I have y is equal to 0 and I have x is equal to 3. That gives me an ordered pair, x, y. Great. We found one intercept. Let's find the other one, the y-intercept. Alright, the y-intercept, if I go up to the right here, this little graph, the y-intercept is where it crosses through the y-axis, so x is 0. Alright, so I'm going to let x equals 0 in my equation, so I have 2 times 0 is equal to 3y plus 6, or 0 is equal to 3y plus 6, or y is equal to, if you work this out, minus 2. I've skipped a couple steps here, so go back and make sure that you can go from 0 equals 3y plus 6 to y equals minus 2. But again, take these two, the x value and the y value, and put them together into an ordered pair, I get 0 and -2. So now we can graph those 2 points. Let's do that. So we had 2 points, 3, 0, and 0, -2. So 1, 2, 3 on the x-axis. 3, 0 is going to plot at 3, 0. Remember I said that was the x-intercept, so that makes sense. It's on the x-axis. The y-axis is the vertical one, and it has 1, I'm going 1, 2, but it actually has a -2, so we'll go the other way. -1, -2, -3. I'll put a scale on this, 1 and 1, so I know I'm counting by ones. And it's at -2, so it's sitting right here. With 2 points, I should be able to draw a line. So let's see if I can do that. No, I'm trying. But anyway, gave me a little extra. Let's get rid of that. Sorry about my line here, but you get the idea, I hope. If my hand was a little steadier, we'd have a nice straight line through those 2 points. So you can just imagine a straight line through those 2 points. If I was doing this on paper, I'd use a ruler, obviously. So how do we check to make sure that's the right line? So let's check. We check by adding in what's called sometimes a checkpoint or another point. So you pick any value for x. Pick x. All right, so let's let's pick 5. So 1, 2, 3, 4, 5. I'm going to pick this value for x, 5. Now, just based on my graph, I can see that this line continues, straight up, right? And when it gets to 5, it's about here. So I'm expecting my y value to be, if it was a good line, maybe the best I can tell you is it's positive, right? Just based on the graph, we could say we think y should be positive. So let's plug in that value of x into our equation. 2x, 2 times 5, was equal to 3y plus 6. This is 10, this is 4 when I subtract 6, and I get y is equal to 4/3, which is 1 1/3. And if I plot that checkpoint at 1 1/3, maybe it's here, but it's pretty close, right? If I drew my my points a little better, you can see that if I went through there, it'd be roughly the same point. I'm looking for something that isn't completely off the scale. Like if I found it to be, say, I got my signs wrong and thought, oh, it's -4/3, I'd be way down here, be off the line completely, and I know that was wrong. And I'd have to go back and check both my intercepts and that point. So that's it. It's pretty easy with intercepts. We just let x equals 0 and find out what point we get. We let y equal 0 and find out what point we get there. And then we just plot the 2 points, pick a checkpoint just to make sure, and life is good. So what about something that looks like y equals 2. That's a nice equation. It's linear. I'm supposed to let y equals 0, aren't I? So let's check this. Let's x-intercept. Let's find out what the x-intercept is. So I say, okay, x-intercept, that's right. I'm going to let y equals 0. So I go back up to my equation. This is my equation, y equals 2, perfectly fine equation. And I think, if I let y equals 0, I put in 0 and I say that equals 2. And I'm not happy about that because I know that 0 does not equal 2. So what's going on? Let's try a table. Let's see if that will make sense to us. Now remember the table we had We put in our x, we put in our y value, which was determined from the equation, so I'm going to put it equals 2, right? That was our equation. That's how I'm going to find y. And then I'm going to get an ordered pair out of this. Okay, so I'll put in an x value of -1. What's my y value? Well, I look at my equation. Y equals 2. Doesn't say anything about x, it just equals 2. Oh, well, there's a point. -1, comma 2. Well, let's let x equal 0. What's y? I look at my equation. There's no x in it, so I can't substitute 0. I just say y equals 2. I'm doing exactly what it tells me, y equals 2. So now I have 0, 2. Put in 1. The same problem keeps occurring. It doesn't matter what x is. I keep getting y is equal to 2. Because y equals 2, it doesn't care what x is. If we were to plot this at 0, oops, what happened to my line? X, y, at 0, 1, 2, 1, 2, -1, -2. At 0, we got 2. At 1, we got 2. At -1, we got 2. And this turns out to be a nice horizontal line at y equals 2. What a surprise. Let's try one more. X equals -3. Notice that notice the second variable, y, is missing. I could put one in. I could say x equals -3 plus 0 times y, right? I could add 0y. So I would have a place to put the values for y, but every time I put one in, I'd multiply it by 0 and I'd add 0. So this whole thing is 0, no matter what y is. So if we really need that second variable, you can throw it in there times 0. But I think it's just as easy to look at this and say, wait a minute, there's no y. So even if I came up with one, there's no place to put it. Here's x. Here's y. 1, 2, 3. 1, 2. 1, and 1. So no matter what I have for y value, x is going to equal -3. So here's -3 if y is 0. Here's -3 if y is 1, if y is 2, if y is -1, I get x equals -3. Just a nice vertical line. Great. Have fun with those.